disseminating near real-time hazards information and flood maps in the Philippines through Web-GIS. This paper aims to explain the program of the Nationwide Operation Assessment Hazard or Project NOAA in disaster prevention and mitigation. Year after year, Philippines is devastated by natural calamities like tropical cyclones, tsunamis, earthquakes, and volcanic eruptions that result in numerous loss of lives, damage to property, and economic losses. In 2011 alone, we experienced at least 3 devastating storms, including tropical storm Sindong, and a year after, another earthquake devastated Bohol Island, killing 222 people. A month later, it was followed by storm surge Haiyan, killing more than 6,300 people. By investing in new technologies and new scientific approaches to disaster mitigation, Project NOAA seeks to enhance disaster management and prevention capacity of the Philippines. Estimation of rainfall. Probability of rain is calculated using process infrared and water vapor satellite image data and Doppler data obtained at near real time in combination with statistical evaluation of historical rainfall. Weather and water level sensors. Automated weather stations are monitoring stations equipped with different sensors capable of measuring wind speed and direction, air temperature, air humidity, air pressure, and rain amount, duration, and intensity. Automated rain gauge stations only measures rainfall amount and intensity. Water level monitoring sensors is equipped with solar panel and make use of ultrasonic sensor to measure the current water level. High-resolution maps provide more detailed scientific analysis of natural hazard phenomena before, during, and after disaster event. Philippines acquired geospatial data through LIDAR and airborne interferometric synthetic aperture radar, a high-resolution digital terrain model, to cover the 300,000 km² land area of the country. One-dimensional and two-dimensional flood simulation and crowdsourcing of flood events. Once a high-resolution topographic maps are made available, different models such as the Hydrologic Engineering Center's Hydraulic Modeling System, FLO 2D, and ICES 2D were used to simulate one-dimensional channel flow and two-dimensional floodplain inundation maps. Probability of rain is displayed as weather icons and percentage chance. Automated weather stations and automated rain gauges record rainfall intensity over time, which are then classified into light, moderate, heavy, intense, or torrential rain, color-coded into light blue, blue, dark blue, orange, and red respectively. Stream gauges or water level monitoring systems are useful for monitoring river flooding. Himawari 8 Satellite 2015 provides images with higher spatial and temporal resolution. Doppler data radar used to detect moisture or precipitation in air and calculate its volume and movement. Detected clouds were colored to represent the calculated rainfall intensity in millimeter per hour. High-resolution static flood maps are necessary for planning emergency responses like evacuation or access routes, and people to become aware of the hazard in their community. Therefore, Project NOAA provides us a website with more available facts that is used to disseminate to public and can be used by local government units in the Philippines in their disaster mitigation and prevention efforts. This latest government initiative promotes frontier science and technology and establishes research and development platforms as key elements to assure homeland security. It is, however, not a complete solution. Society would need to embrace the program and make it a rallying point for establishing a culture of safety. No matter how much the government delivers, it still depends on the people on how to use it wisely.